20 feet.
Hello, everybody. So, thank you for making the class today. I know last week I said we were only going to do one day this week, but we are very restricted on time. And the biggest thing with game development is it is very time consuming. And I didn't want to just lose a whole day of class because the same thing's going to happen next week. I guess that's a good part to start with. Next week, if you haven't heard yet, you should have received an announcement about it. But since things are going on all across the state of Indiana, all of the campuses are going to be closed on Monday. So our campus is closed. The college will be operating virtually. Oh, let me let her in the room and then I'll say that. Okay, yeah, so next Monday, the college is operating virtually for a 10-minute event in the afternoon. Be virtual all day, but that. And then Wednesday, just like this week, it was a whole day of class. So the person that I'm riding with to the event next week, there's a whole bunch of us going, so there's like 4 of us and 4 or 5 of us in every one of the school's vehicles. But they sent out a calendar invite and said that they're going to leave at 2:30 or 2:45, so we will still have at least an hour for class. So I'd rather not give up that hour because game development can be a little time consuming. We've got a lot of stuff we can cover, and so next Monday will be virtual. And then Wednesday will probably only be about an hour and 15 minutes long. As I thought about it, well, for one thing, 4 hours of lecture, that's rough, right? There's no way you're absorbing information 3 hours into a lecture. So trying to put all of it in one day is just way too much information. So I said I don't want to just cancel class. It was today and then next Wednesday. So class will be short next Wednesday and virtual on Monday. So some of y'all that regularly attend here in classroom, if you want to do virtual both days, it'll only be an hour of class. So this is the only reason you come up here. And maybe you drive for like 45 minutes. So let me hand this flyer up to the people in the classroom. I gave you one of these, Grace. So just doing some promotional things for the people in the classroom. For those on the Zoom call, it's the School of Business annually does an etiquette dinner, a really fancy meal, one of those super formal things where they have like 10 different forks and 5 spoons and how to use each one and all the proper go over all the proper table manners and stuff, because that's an important thing. That's an important professional thing, right? Go to a professional dinner, you want to make sure you know all that stuff. And at the very least, it's a really good free meal. It's not like afternoon pizza and chips sort of thing. It's going to be a fancy 5-course meal. That way they can show you how to use all the proper fork for each one of the courses, all of that stuff. And, they do it every year, but definitely worth attending. Yeah, it looks like there are a couple Sellersburg students on the Zoom call, so I will send that out coming up soon as well. On April 29th is the School of Business's etiquette dinner. Here.
Do you need to dress up for it, or is it just come as whatever?
I've seen people dress up before, but you can come as whatever. Some people do like to dress up for it. So check with some of the people that might be coming. Check with any of your peers that are business majors. Might be the best person to ask. Or I can ask and get you a definite answer. But I've seen people go both ways since it is like formal dinner sort of thing, because especially for the ladies, if you're in a cocktail dress, it doesn't move the same as jeans and a hoodie. Right? sit different than normal. So it falls under practice that way. So some people do dress up, but also it happens at lunchtime on a normal day. So some people forget about it, and then when they get to campus that day, they smell food and they're like, "Oh yeah, need to go to that event with free food."
If everybody wants free food, we have it here.
Yes. For those in the lab today, there's food left over from the event. So, oh, but it looks like I see some wraps over there still. So, okay, so for our stuff, one quick note: I had forgotten to put something in the instructions on the discussion board. This discussion board should have 2 due dates, right? Like, well, I'm gonna forget it, but I copied and pasted from a previous semester where the homework was due on Wednesday. So it said turning your first post on Monday, and then there was like 3 more days to discuss. But our homework's due on Monday, so Sunday's kind of late to give your classmates time to reply to your post. So I guess it wasn't something I forgot. I forgot to edit and correct it. So I did go back and correct it. So moving forward, I believe I put Friday on there. Make sure you put your initial post by Friday, and then there's all weekend, the whole weekend for your classmates to post. But it looks like a couple people have already jumped ahead and started doing some of the other ones. So what happened in this class last time? People really seem to enjoy that discussion board, and that is a standard practice in game development. Somebody will come up with just the basic plot like that, and then the rest of the team will decide how to tell that story. Which next week, possibly the Monday after, we're going to get into storytelling. Like the lecture notes for that day were borrowed from the person that teaches creative writing, the English 230 something here at campus. It's like I want to make sure and accentuate that connection that we're telling a story with games. That's really what we're doing, and simulations. We're mostly a lot more interested in the games, but the same skills pay better with simulations for engineers, so keep that in mind. But we're telling a story, so we'll get into storytelling stuff, and that's what the stuff the other day was about. We were talking a little bit about physics, just a basic introduction. I'm always a little nervous on that particular lecture on how much to include, because everybody has a different math background coming in here, right? If it was an actual physics 1 class, you know what math people have had before they come in there. So I didn't want to get too in depth in the math and into the math, but still see the equations and formulas, because we will need them, especially when debugging. If everything works right, then just play the game. But when things go wrong, you don't want to just randomly make changes hoping that one of the changes is going to fix it. Because there's so many things to change. It's unlikely that you're randomly going to find that. But that's the story that's part of the story we're telling, how things interact with each other. The lecture from the other day, and what we're going to look at here in our example today a little bit, relates to the laws of physics, motions, Newtonian physics mostly, motion and energy and things. But that's not the most critical part for game development. So like I'm standing up here in front of the class and I jump up and come back down. All of the laws of physics, well, there's stuff going on everywhere, but as far as the jumping up and coming back down, there's only one spot that really applies. Actually, 2 spots. Right? Between the bottom of my feet and the ground is the only place where the physics matter in that act of jumping up and coming back down. So that boundary, the edge of things, that's what we have to have from the physics engine. That's what the physics engine, that's why the physics engine is one of the critical components. You can't have a game engine without it. Because physics apply as the boundary between things. So that's kind of what we'll look at today. And then in the Newtonian physics, because we want our stuff to move. But let's start a new game and look at some of some of what we have with the boundaries between things. And actually, I'm gonna do a 3D game first this time. Do some quick 3D stuff instead of 2D stuff. Open Godot. We'll bring it back to the 2-dimension, but since our instincts all apply to the 3-dimensional world, I just think this makes more sense to start in the 3-dimensional world. So we'll make a couple button, couple things that we can picture with. So I'm gonna create a new game. I'll just call this boundary. Again, this is probably one I'm just gonna delete afterwards, just pointing at some examples. And then after we look at some physics stuff for about half an hour, maybe 45 minutes here, then we're gonna look at tile sets and what will be involved in the first programming assignment, which will be a very quick, a quick introduction to them, because once again, it's, if you've never seen them before, we'll do a quick introduction today, and then you click around on them a little bit, and then we'll look at them again briefly on Monday after you've clicked around and seen the buttons and kind of seen what's there with them. So the 3D world, new project, and I started the Godot project first because I need a couple items to put in here. Could use just a plane. There's like small meshes we can work with here. There's some editing functions, so we can make our models here, but Blender has better editing functionality, and Blender is fully integrated into Godot. So really all it takes to get our models in between Blender and Godot is just to save them in the project folder, and Godot will recognize them. So I'm also going to start a couple quick models. We could do some oversimplified things, but also I want to show y'all where a really useful button is. And a better world to work with here. So I'm starting a new general project in Blender, and then get rid of all this stuff. I'm just hit A to select all of it, and then delete. Those are our main 148 class. I've already seen this, but we need a landscape for our character to walk around in. Character is probably just going to be a cube today, but for a landscape, I didn't want to just walk a cube around a flat plane, so we can talk a little bit more in depth about boundaries. Blender has a really great button for this. We could quickly make something, but if you go to Edit and Preferences, and then on the Add-ons tab, there are a bunch of things in Blender, as if there weren't enough buttons already. There are a bunch of plugins that just aren't turned on. And then there are a lot more we can download. It's open source software. There's a lot of people that spend lots of time making plugins. I'm one of them. It's really, really fun. And really, really easy. So massive software, but the one we want to look for now, if you look for landscape, start searching for landscape, you'll see this add mesh ANT landscape. You just hit the checkbox, which this one takes a minute to check. You click, and then it has to do all sorts of stuff in the background, but eventually it'll the checkmark here. And when the check mark is there, you notice there's no OK button or anything. Once the check mark appears, just close out of this. And then under the add button, when we go to add a mesh, instead of just our primitive types, I'll put a landscape, a button just to add a landscape in. It's a parameterized landscape, so it's the sort of thing that's better for coders. We'll also pick a tree. We had an assignment last week to make a tree. We'll see an insert tree button the same way. So you'll see it just automatically put in this little mountain hill thing. Before you do anything else, you want to expand the little button, the little box at the bottom left. These are all the parameters for that landscape. And we have lots of control over it. So like how refined it is. The general size, we'll get that in a moment. You can leave those the same, but down here, just roll it around so that I'm just clicking and dragging the slider so that your goals might be in a different place. The size refers to like how tall the hills are, how deep the bumps are, and things like that. Depth of it, you can play with different things, or there's a bunch of presets up at the top. You go to operator presets. You want like some deep canyon for characters to walk around in, or
Where did you put that box?
this stuff here. So as soon as you insert it, so add landscape. So I already lost the box. So you have to do it immediately. I accidentally clicked somewhere else. Add landscape. And then once it shows up, it's it might be collapsed like this down at the bottom left. See your screen real quick. It should show all of the previous stuff. So if you delete that one, and as soon as you click somewhere else, that goes away. So this is all the parameters, right? There's a pre-built function. That's all it is, just a function that inserts a plane and then makes a bunch of modifications to it. And these are all the parameters that we would pass into it, just nicely put in the GUI. You can come over to the scripting tab and type it in yourself, but it's kind of nice with the GUI there. Different areas for our character to walk around in. You can kind of mess with those. Maybe I'll go with lake. Yeah, I'll choose a lake, and notice the lake has two parts. It's got a flat plane surface for the water and one for the land. And then after you get all those settings chosen, just click anywhere in the empty space to deselect it. I'm going to give these names real quick, because I can't tell which one's which. Looks like when I click on the top one, I can see the highlighting going over the hills, so that must be the ground. And then the other one would be the water, just the flat plane. That way we can tell what's what when we get over to our game engine and maybe give it some colors. So we saw that the other day with it selected, scroll down to the beach ball looking thing and click a new, create a new material and then something blue. I'll just click on base color and choose a bluish color. Oh, let's go with a simple material. And when we get to shaders, I keep choosing a simple material. We can use either one. Godot knows both of them when they import. And water is going to be pretty reflective. So lots of metallic, lots of specular, and almost no roughness to it. And then the ground, I'll click use nodes again, some sort of greenish color, maybe a little darker, and it's going to be like ground, so almost no metallic or specular, and then just all roughness on that. A couple quick materials so we can see something. I guess the thing is, though, it's really small, right? We can see on the grid, the grid's marking out 1 by 1 meter by 1 meter squares. So that's not much of ground to walk around on. So I like to scale it up a little. Right? If that's a big lake, that's should probably be like a kilometer by a kilometer, right? A nice large area to walk around on. So I'm gonna come back to that orange button for the transform and just scale the X and Y stuff up. Like 500 by 500. And Z as well, I guess. Scale all of them up to like 500 by 500. Whoops. I didn't mean to bend my Why is that? That might be a little bit big. Maybe 100 is probably enough for today's example. But scale it up enough that our character can walk around. And by default, the units are going to be in meters. I'll show you how to change that at some point, but there's so many times we're going to come over here and click on buttons. I don't want to overwhelm you with buttons at once. That's probably a better size. So once again, I'll hit Control A and apply those transforms. So now that 100 times bigger becomes the new 100% scale size. And probably need to do the same thing on the water. Make it 100 times bigger in every dimension. Then hit Control A and apply those transforms. And it gives us a nice little landscape for our character to walk around in. It's not a flat plane. Something a little more interesting is going to happen with that. Then I'll save that. And when you save it, just go to the project, the Godot project. So it's important to create the Godot, the project first, which I guess is this one. I'll just save it there. Oh, probably shouldn't have called it untitled, but maybe give it a good name. Then when we go back over to Godot, it'll take it a minute to import because it is a fairly large one. Hopefully not too long. Okay. That was longer than I expected. Probably the Zoom call slowing stuff down. Then we have this model that we can use to make, bring it to a scene. So I'm going to create a new 3D scene. I'll just make a base node here to be the root of everything. And we grab that model and just drag it up there. To bring that in as a ground for our character to walk around in. We'll see improvements on how to bring that in. If you double click on the model, it'll open up this little box here eventually, where we can change all the settings on how it comes in. You can see we can still get to all the different parts of it, the meshes, the materials, and we have control over how it brings in, how it gets imported. But we'll get there eventually. For now, just bring a model in, and that'll be our world. And need some sort of character in there, which I'm just going to create the character here for a little bit of variety. I'm going to go back to the root node and add a new node. And I was trying to think of a good way to introduce the term, but it's just a long one. So a mesh instance 3D is where we create the meshes like what we create in Blender. I'll create that. I come over to the hierarchy. I probably should have done this first. Notice how it came in as one object, but there's a bunch of pieces to that, right? There's two different meshes and materials. We don't have any animations, but we could do some animations, make that like a volcano so that it's growing or something. That would be a really neat animation.
Move the water up and down.
Right. That one you could probably animate without even using a skeleton. Just start adjusting the mesh and sort of swell it up to the top and then suddenly have it explode and have another mesh come out like lava. Wouldn't be a very hard animation to make, especially with that as a starting point. That just popped in my mind, but it's something that happens with game development. You'll see ideas, follow through on those ideas. It doesn't have to get to the final draft, but take a few steps on something like that. And at the very least, it's good practice with modeling.
The infamous Minecraft creeper was because the notch messed up the dimensions he entered.
Yes, it happens. There's been a lot of things that happen, just happy little accidents, or people just ask, what would happen if I did this instead? instead of following that tutorial exactly, what if I did this instead? And we get some really neat things happening. So we'll need to access stuff at different points. So I'm going to right click on that one that we imported, because notice it has the icon of just that basic 3D node icon. And we're kind of restricted on that. If we right click on it and come down to editable children, that'll expand out all the components. And notice now we have the same icon as the mesh we created here. So we can get to each part individually still. And anytime you bring something in from Blender, you're going to want to do that. Expand it and click editable children. This mesh instance is going to be our player eventually. I'm going to make some changes along the way, but for the mesh, I want to, if we select in the hierarchy over in the inspector right now, it says empty. I'm going to give it some sort of shape. A cylinder will work for now. I'll just give it a basic cylinder shape. And there's a skeleton. So we can do the we can do those armature style animations like we were doing in Blender, but they're kind of hard to edit here. There's somebody that's working on a nicer editor for them, open source project, but it's somebody that has a full-time job, so it's hard to say when they're going to get finished. And it's an amazingly difficult thing to actually get all the code in. So somebody doing it in their spare time after their full-time job, we don't want to rush them. It'll be here eventually, a nicer editor, but yeah, not impossible, but it's fully integrated with Blender. Blender has way more features, so they're only going to go so far. They're just doing a basic one. Because
oops, I screwed something up. I don't open Blender to screw with it. Just eat.
yeah, just that's really what it's going to be for, so you can better edit the ones in Blender. The right below that is surface material. So if we extend this, you'll see a couple options: a new standard material, ORM material, or shader material. Probably we'll get to shaders eventually. Shaders are where we code the material, so they're dynamic. If we go with the standard material, when we click on this, we'll see a bunch of things like we saw in Blender. The transparency of it, the shading, the coloring, the normal maps, rims. You'll see UV all over the place. U and V are just the next best letters to use for XY. Right? We used XY in our main game. So we want to use a subset of coordinates for the local materials and stuff. That's what UV is. It doesn't have anything to do with like ultraviolet light or any of that stuff. It is just, if you've never heard it in a math class, letters at the beginning of the alphabet are ones we know, right? A, B's, and C's, those are constants that we'll know when we actually go to solve the problem. Ones at the end of the alphabet are variables, X and Y, and then the ones in the middle of the alphabet, N's, M's, K's, I's, those are like index ones that we will figure out along the way. We usually have multiple of them. That's the convention. So whenever you see UV, that's just the next best letters after X and Y. We already used X and Y. Albedo's the color. That's probably the main thing we need. Always click the shade first, otherwise you're always looking at a black or a white. These editors here, we talk about color space being a vector. We can kind of see it as a vector here, right? When we look at a wheel, we can see what would be meant by a direction in color space. This is our player, so something skin color looks like it's over here somewhere. That'll work.
The skin cylinder.
Yes. It's really small. That great big world, we're looking at the whole thing. This is a convention in most game engines. I'm gonna put my mouse somewhere here in the middle, make sure the player's selected, and push F to focus. F is focus, and then after you do that, that becomes the thing that you zoom in on. If your cursor is somewhere else, where's panning? That's Alt, Control. but that's standard in most of our game engines. Just put your mouse in the viewport and push F, and then the thing that's highlighted gets focus. So it becomes the center of the screen. And you can zoom right in and out of that one particular object. That's not a very good spot to start, so maybe start him over here on some land. Or her. And what I just did there is something you want to, we could move it, grab it in the middle and try to move it in all 3 dimensions at once. But it is a whole lot easier, like programming. It's a whole lot easier to deal with just one axis at a time. You get a good starting point. And that's the first part we'd have in a game, right? Our graphics hanging out in space. But they're not doing anything. Right now, they're only graphics. We need to apply some physics. There's a couple options we have. So I'm going to go back to the root. And I'm going to make those graphics the child of a physics object. I'm going to go back to the root and click the plus sign and search for the word body. And notice we have several to choose from. There's a static body, animatable body, character body, rigid body, and vehicle body. And you'll see that some of them are child classes of another one. Our basic 2 are going to be static body and rigid bodies. Character body is actually a child of rigid body, but they separated it off because it's such a unique thing. It's a child of rigid body that we put a bunch of locks on. So one big thing with characters is we don't notice it because we're used to moving, but humans have very poor balance. We're constantly rebalancing ourselves. With every breath, your abdominal muscles are rebalancing yourself. But we don't have our game characters do that. So if we have like a human shaped character in our game, the slightest bump is going to send it tumbling. Because our center of gravity isn't really in the middle. Kind of in the middle. It seems like the middle does, but the center of gravity isn't the center of our mass isn't the center of our shape. They're not lined up. So we don't notice it, but so we have to lock a lot of the regular laws of physics out of a rigid body. A rigid body gets all the laws of physics. The static body gets all of the laws of physics, but it doesn't move. Think of it as something like we lock it down enough that it's not going to move like a wall. It's still going to have all that stuff, but we don't have to put a massive mass and build a foundation and go through and hit a bunch of check boxes and adjust it so that it never moves or anything, or the ground itself. So the ground would be a static body, and our character would be a rigid body, but in pretty much all of our game engines, we have a subset of rigid bodies for character bodies that just already set up to move and stuff. Play around with some rigid bodies. Our class is obviously short on time, so we have extra time on everyday schedules so that you can go in here and click on stuff. Play around with some rigid bodies and watch what happens when they hit different uneven ground that we're standing above. I'm choosing a character body to represent that character or the player. Let's get a little warning. It has no shape, which is kind of important. So go in the player and drag that in. There's actually 2 warnings. If we made that go away, another less important warning would show up that has no graphics. But if it's no shape to it, is more important than graphics, but they are not the same thing. The character body, we got our player and shape. The node, I was trying to read that. The node has no shape, so it can't collide or interact with anything else. I'm going to click on this material and Here's something, I moved the character too soon though. There's where the computer thinks its shape is at. We haven't given it a shape yet, but the computer thinks it's right there, but our graphics are way over there. So we probably want to realign those. So I'm gonna go to the player. And under transform, notice that the position has changed. If you switch that back to 0, 0, 0, now now the computer thinks the graphics and the physical boundary are in the same spot. But we need to address that warning label. And there's a couple ways we can do that. We can add a node. I want to search for it. Yeah, collision shape, or it add, ours is just a basic collision cylinder here. So if we add a collision shape, there's an easier way we're going to see in just a moment. I want to do the basic one first. Still have a warning, but we have the node to represent our shape. So the physical body, or what the computer thinks is a physical body, no longer has a warning, but we have a spot to be a shape, but no shape in it. And if you come over to the inspector, you'll notice it's empty. Once again, we just click on that and choose some shape for it. Obviously, cylinder would probably make the most sense, but let's try some different ones. We put a box around it. This sort of that is not the shape. So we're in a situation where the shape does not match up with the graphics. Which seems like it could be a problem, but you want to be careful with that. We're going to see an error that's going to creep in a moment. Not really an error. My computer will run it, but that's a box. It takes 8 points in space to define a box, right? So that's 8. Each one's has 3 coordinates, floating point numbers, 64 bits. So 8 times 3 times 64 is a fairly large number, but not too large for the computer to handle, right? Versus a cylinder, if I was to do the cylinder shape, which actually, I don't know how well it's going to show here. If I was to come over here, and that, since it's not empty anymore, I have to actually click the arrow and put a cylinder shape. It perfectly fits our cylinder, but the top of the cylinder there has a whole lot of points. Anybody use a cylinder when they were doing the Blender assignments this week? Did you see how many points it has around the top and the bottom? Each one of those is a 3-digit number. There's more than 8, right? So a box is a lot smaller. And that's what a GPU is moving. That's what your GPU is moving, all of those vertex points. So if you perfectly line it up to your picture like this, even on the cylinder, we have all the points from the shape and all the points from the graphics that have to move, which is a lot of numbers. That's why GPUs have to get so big. And this class, I assume most of y'all have played a video game before. You also know how hot GPUs can get. And CPUs, if you don't have a GPU, and if you're developing games, you can't really guarantee that your players are going to have a GPU. You put it on a list, like, yeah, you probably need a 4080 to play this game, but that doesn't mean people aren't going to download it and try it, right? How often do we really pay attention to those lists? So keep that in mind. We want to minimize that, which isn't a big deal on this one. Let me move that back over where there's some land. 1 axis at a time. It's not that much slower than trying to move them in 3D space, but if you try to move them in 3D space, you'd end up with a problem. Oh, look what happened.
They're not moving together.
Yep. I moved the shape, not the graphics, and not the physical body. So we really need all of those to happen at the same place. So I'm going to come back to transform and set that in 0, 0, 0. Make sure you always move the parent object. That would land, there's not much land there, I'll move away over here. Notice that when I zoom in and out, straight in and out, I'm no longer looking at the character, that's what that F thing is about. So I push the F key, it moves it so the character is right in the center of the screen and I can find a good spot. Over the years, what I've found to be about the best option is you want to try and find a spot above the ground, because if you're like sticking in the ground or something, the game could register a collision and your character is like stuck on the first frame. So I always try to go just a little bit above the ground, but like an inch or two above the ground. Something that definitely will hit the ground in the first frame of the game, so the player will never notice that one frame thing. Which, speaking of frames, I kept making that point the other day and never mentioned the frame rate. When I was talking about like friction slowing a character down and stuff, remember we're talking about frames. So if your character is moving at 5 pixels per frame, it doesn't take very many frames to slow down to a complete stop. It doesn't stop in, what I was trying to say the other day, it doesn't stop in one single frame when you release the button. Give your characters enough time to a couple frames wiggle room, I guess, basically. I found it's useful to put the stuff right above the ground to start. So our character, no more warnings. We have the physical body. This is the logical body. Have all 3 parts in all of our game objects. This is the logical body. This is the one we write the code for. And it is the parent of the graphics, the ones we can see and react to. And the logical body is also the parent of the shape. And the shape would be the physical body. It's the one that has the boundary. That'd be good. Probably go ahead and give this a run, see what happens. See the first little error. You probably already know what's going to happen, right? Oh, well, for one, we can't see anything because there's no light.
Well, there's also no camera.
Yes, no light, no camera, we can't see anything. So, not quite enough to run anything. It didn't just automatically crash, that's a start. So let's add a camera. Let's add a light. There's multiple types of light, we'll see them soon. Directional light is, that's like a sunlight. Basically, it's really, really bright, illuminates everything, has a lot of ambient light, so bouncing off and stuff. And we just kind of think of it as that direction is the angle the sun is coming in at. So you can move it and change the direction to simulate passage of time. Omni-light is like a torch. We have a little central point and then light just spreads out from that. So a torch is a good example. We put an omni-light at the end of a graphics of a stick, and then there's a small bubble of light that our character has to move around in order to see. Then a spotlight is just a spotlight. It comes out as a big cone and covers a very specific area. So I had a light there. It does not matter where we put this. What matters is the little arrow. So you can see that right now it's pointing, let's call that east, pointing just one direction straight off. We'll call that east. If I grab this and spin it around, you can see the shadows changing over until it's pointing at west. And so all we have to do to change passage of time is just rotate that. We don't necessarily have to move it. Point it straight up and it's almost like dark. It's not really, that's not quite for simulation, but find a good angle for the light to come in at. I'll just pick a random one there. And it doesn't matter where we put that, so I usually just drag it out of the way so that I can select other stuff. And then we can't see anything until we put a camera on. Is it stuck?
I think so.
Oh,
Sorry.
so I'm gonna go back to the character. I think for today, I'm just gonna put a camera in the room. This seems really, really strange. I almost always attach cameras to characters, but if we search for camera, you'll notice the blue and pink icons. So there's a camera 2D, a camera 3D, and then the XR is the cross reality. So augmented and virtual reality. There's another one. What's the E? AR, VR, and ER.
And that's for use with the.
What's the ER? I can't remember what E stands for. But augmented reality and virtual reality are the ones we're probably worried about the most. I only heard about it recently.
I was about to, I think that was a thing, but they rolled it in, like it got like there were three, but then they basically kind of like AR is kind of
XR is the everything, yeah. So yeah, XR is the virtual reality camera or augmented reality. There's more than just those three. Those are the big three. They're really the big two. I only learned about the ER recently and was like, oh, I'm surprised I haven't encountered that before. Here we just need a basic camera. And we've got preview. Looks like the camera went back to the origin and it's just pointing off at some default view. I'll move it like way over here. If I zoom in on that camera, there's kind of a shape. See the purple lines? Give you an idea of where it's pointing at. And grab the little wheels, rotate it. There's a checkbox to see preview, so you can see where you're pointing at. I guess I could move a little closer to the character. That'll work. You can see the character there. So now we'll be able to see stuff, have some light. We'll talk about world environments and stuff before long. I'm just gonna hit run. Notice it auto saves every time we hit run. Nothing's really happening. Right now, we still only have the graphics. I'm gonna come over here to this character body. Maybe I will just do the rigid body. We're gonna see we'll switch to character body. If I go to change type and rigid body is our basic ones that has all of the laws of physics apply. Got the shape, the part we need, but then everything else from physics. So if I select it, I'm rename that body. So it's a rigid body. I meant to look at the inspector before switching that, but we have more things here. Notice there's things that relate to physics. So the mass, that showed up in every one of those equations we talked about the other day, didn't it? Pretty sure it was in every single equation I put on the quiz. The M. So we can type in the number of where the mass is, right? 76. That's a medium, 76 kilograms. Obviously, we can change it to the empirical units, but the metric units have some advantages, and most of your things can be set by metric units by default. So you might want to get used to at least some basic things like what the average human male would weigh. What type of material is it? Right, we can come in here, and the friction was important. Right, we talked about that the other day. So there's where that box is if you want to try to put that in. That formula for friction, think of it as just a scaling factor. It almost never makes it bigger than one. It always scales it down. But it goes with our normal force, that equal and opposite. And that's what's used to slow things down. So we would set friction for the bottom of our character and friction for the ground. And then when our character moves across the ground, there's always that friction slowing it down, like the way we move. All of that stuff is built in. We have all the laws of physics. That's why I just asked you on the quiz to identify the formulas, because we're only really needing the intuition on them for debugging. The computer's going to do the calculations. They're built in. That particular one, I found it can make things a lot easier if you just wait and hard code the friction where you need it, instead of using the built-in friction, because it's one of those things, once you start setting friction on a game object, you pretty much need to set the friction on every single game object in your game. And that adds up a lot of time versus hard coding the one line into the script on the 3 spots you're going to need it. But, right, we have all, if we go to the rigid body, we have all our physics here. Set up some material, how rough is it? Is it bouncy? Is it absorbent? Or we can just load in materials. Let me clear that out. Clear that. It's also a mass distribution. So remember, inertia is an important thing. That's Newton's. That was in the quiz. Newton's first law. Quiz question. So I'll go ahead and say it again in lecture. That's the one that gave the astronauts trouble. An object in motion stays in motion. Astronauts were used to moving heavy backpacks. Those guys had no trouble carrying a 200-pound backpack. They did that a lot on Earth, except for one difference. They trained in a pool, which had resistance, and the inertia on the moon was the same. So stopping that 200-pound backpack from moving took the same amount of effort as it does on Earth, but not really. They tried to go back to what they normally do, thinking it was the pool that was so involved. But air is also really thick. We don't think about it, but air puts a lot of resistance, right? If I drop this notebook, it slows down, and that's there's a bunch of paper there. Air slows things down a lot. So without air resistance, those 200-pound backpacks the astronauts had wanted to keep moving in their suits. It was really, really hard to stop their suits.
I imagine it also, because that inertia isn't just continuous movement, it's also start movement. It also meant starting was a pain in the butt too, because of the whole issue of friction and everything.
Starting was more like on Earth. Actually, starting might have been easier than Earth, because on Earth we have to start against air resistance. But it was definitely throwing them off. So all that stuff in there, you'll want to, again, you're going to want to click around and look at what's on here. But the words that we saw in class the other day, friction, inertia, right? And the inertia is spread for the distribution. So that, think of those X, Y, Z coordinates as like where that's centered at. Right now it's at 0, 0, 0, which is the origin, which usually on our players is probably going to be the bottom of the feet, but that's not where our mass is centered at. If it's human shape, our mass should be centered up here somewhere, right? Where we have all the heavy ribs, and there's more cortical bones than tenacular in the top half of your body, which adds a lot of weight, plus all your organs up here.
Humans are top heavy.
Humans are top heavy, yes, exactly. So we would probably want to move that up the y-axis. The average human male is 1.8. I put in the average male mass.
I will say
1.8 meters tall. So we probably want to move that up about 1.2 meters or so.
though it does, in this particular case, due to the way it spawns in objects, that the mass is already in the middle.
Yeah, and if you're doing this for an engineering simulation, the engineer will tell you exactly where the center, exactly what values to put in there.
Isn't that right? Isn't where the arrows are originating from on there?
Right now it's about the center.
That's basically pointing where it's thinking the origin point is.
Yes.
So 0, 0.
Yeah, we choose where the origin is, by the way. And we'll talk about that thing. There's some options are better than others. Deactivation, this is what was set for, is preset on the character body. We freeze the rotation so that our character doesn't just randomly start spinning, like we're gonna see in a moment. But all that stuff's happening. There should be gravity on here somewhere.
That's also in some games save processing power by having it where if your player is not messing with something, it doesn't get calculated.
Yeah.
That way they don't have everything in your viewport being calculated simultaneously and lagging the heck out of you.
Let's see if gravity's on here. I was expecting gravity on this. Okay. So it fell, but all we did was the body. We've only defined that character body. But we did all the talking, so the other one will go quicker. And we did all the talking, so I'm going to go with an easier button too. So let me spin this. Any questions about some of that stuff? And we're short on time, mostly that stuff we talked about the other day, physics and your intuition is built in there. So make sure you spend a bunch of time clicking around this, we'll talk about collision layers, clicking around here, not just your transform. Transform is what we're mostly controlling with the game, but make sure you do some clicking around to see what else is there. Our world, we fell right through it, right? Fell right through the ground. That shouldn't be happening. So if I click on the mesh, notice right over here, there's a button that if I click on that whole world object versus the mesh graphics, another button shows up there in the top middle. If it appears in the top middle of the screen, it's probably an important button, right? This is a shortcut for all that stuff I was just talking about. Because right now, there's no, oh, well, we can see it on the label. The very top one, create tri-mesh static body. A static, we talked about a static body, that's the laws of physics always lock in place. So think about it as like the massive masses like the Earth. Technically, it moves when we bump into it, but because momentum is conserved. But all of that momentum from us bumping into the Earth is reflected back into our bodies. Not, we need a whole lot of zeros
That's
between
so
the
much
decimal point
inertia,
and
you're
the
not-
digits to show how much Earth moves when we do that. Enough that we're going to call it zero, because nobody's ever going to take the time to write down how small of that, a number that small. So a static body, but notice there's a bunch of options. We can do try mesh static body. Look at that nice little collision shape that it created for us. It's like perfectly on the ground everywhere. But every single place those lines cross, that's all the witness sees in there. Every single one of those is 3 64-bit numbers. That's a lot of processing power to do that. And you might remember a few minutes ago, I made this smaller than I wanted to. I was like, oh, that's a lake, so probably a kilometer in each direction, like a nice little world space. So really, this should be twice as big as, quite a bit bigger than what I'd originally wanted. It's just we don't all show it once. So we run this now, we should at least not fall through the ground. But the laws of physics happen, right? Momentum's conserved. Came down, the motion kept it going, moved it back up. I was expecting it to roll. I tried to pick a spot where I thought it would
It rolled a little bit.
bounce. It bounced a little. I was expecting it to, since it's cylindrical, I was expecting it to roll down the hill too.
I think it rolled up a little bit
Oh, did it go up?
in its top.
Probably found just a little divot where it's perfectly. in
Oh,
line.
yeah. It is rolling. Okay, yeah. It hit a divot and then tried to roll out of the divot and stop. But all the laws of physics apply, so that's where the character body comes in. Because usually we don't want to go through a programmer center of mass and all of that unless it's relevant to our game. If we're just walking around a 3D open world, we just want the basic stuff. So I'm gonna switch that body back to a character body. Right click on it and change type. And character bodies and vehicle bodies are just kind of preset. So now we still have some physics, but we don't get them in the inspector panel. They're hard coded. Basic, say different. They're compiled into the object. So they're not editable like they are in a rigid body. It's like we know that physics is there, but we're not going to change it because this is a character. So this is what we would encode into a rigid body. But notice it stays upright like a person standing on that ground. It's also the templates. Now if I select that body and click add a script, right, the body, that's our logical body. The mesh is our graphical body. And the shape, collision shape, is our physical body. Takes all three parts to put together for a game engine. Probably have some audio in there at some point too. This seems odd to not have any sound coming from it, but we'll get there. I'm just gonna keep that default name, but notice it starts with a template. So a lot of our things that aren't just a basic node have a template for what they're supposed to be. Character body has kind of a nice one. We're going to create. Oh, again, I just saved it at the top level, but organization goes a long way. Starting, the first 4 weeks, there's a lot of content, and basically the second 4 weeks, all we're going to do is make games for the class examples. We're just going to sit there and do class examples because hopefully all the talking will be out of the way by then. So notice we have a few things. So there's a speed built in, a velocity, or a jump velocity. Gravity is hard coded in here. Semi-hard coded, it goes and grabs it from a configuration file. Physics process, if it's on the floor, set the y velocity to something with gravity. If we push whatever this input is, that must be space, that must be enter, I think. Space key might also be set for it. Set the y velocity to the other one, so we can jump left, right, up and down, all do something. And then we take our velocity and change it one direction at a time. So this is oversimplified and not the best movement. We want to adjust this movement. But it gives us some basic movement right off the bat. So if we hit run, we can press the space bar, which apparently the Godot engine calls UI underscore accept. Space would be a much better name for it, right? If we use the arrows, we can move left and right, forward and backward. No rotation, we can't really tell on the cylinder. But notice how we're perfectly following that world. Which, again, it's going to be relative to the game. But when we set that collision shape to, well, we can see what's concave there. So it's set to a concave polygon. So it perfectly follows that model. That might be a lot more than we need. If we can back it off, it's often a good idea too. So let me delete those real quick, and then we'll improve that movement script after a break. But so this seems like a good place to do this. I'm going to delete those things we put on the mesh. I'll control for multiple selections, and hit delete for those nodes. I go back to the ground and under mesh, instead of doing a tri-mesh static, because that perfectly fits it. Ish. We'll see this again soon when we're actually making a 3D world game. In week 6, so that we're ready to do VR stuff, or that we're ready to do XR stuff in week 7, which I have hopefully have the VR lab set up because I was told meta executives are going to be here to tour their new facility sometime this spring, so I gotta get that. So I need to get that lab set up very, very soon. That door, but that's a distraction. Let's try this without getting distracted. So I'm gonna select the ground. Tri-mesh static fit perfectly, but there's a lot of numbers. The issue that would happen with that is that landscape we inserted is shaded smooth, so they smoothed off around corners already. So what the computer processes doesn't perfectly match what we see. The computer still has all the sharp corners, but we're seeing a smoothed off version. So there's some spots where that's not perfectly aligned, but it's pretty close. And if we turn off the smooth shading in Blender, then it would perfectly fit. But there's a lot of numbers there, so it might be better to use one of the other ones. Some collision siblings.
It truly does.
Convex. We have a couple different options. Navigation meshes for the AI traveling. We'll get to there. Week 6, I think. Tri-mesh covers everything. Single convex, simplified convex, so that tries to do a pretty good job without being the perfect match to make it obviously use a lot less vertices, which is going to make your processing happen a lot quicker. Simplified one, it's gonna simplify it even more. If I click on this, that probably simplified it too much, because look what it does on these hills. It just skimmed right over the top of the hills and our boundaries 30 feet above the lake.
Yeah.
So too much on that one. Single convex.
Are you pressing a certain button to preview this?
No, it just shows. It should show. If it doesn't show to you, it's the little eyeball show beside it.
Yeah.
That again, it looks like it overestimated because of that hill there in the middle. But there's different options, and the big thing is you don't want to overdo it. Because if you do that perfect tri-mesh static every single time, I almost always do it on the ground, but if you do that on the ground and your player and every NPC and every mob and every background object in your game, that's a lot of vertices that the GPU has to process. And I say GPU at that point because there's no possible way that your CPU anybody's CPU is going to do that.
I just hit the multiple thing and holy crap.
Yeah. Look for minimizations when you can get it. I found that the ground, we want our characters all walking right on the ground. So that one needs to be pretty precise. So we'll need to save space elsewhere. But something to keep in mind. Yeah. See how easy it is to get a 3D game started in Godot? Already moving, not very good. I prefer WASD to the arrows. And also like yaw pitch and roll movement. So instead of just like moving left and right this way, because that just feels very unnatural. Yaw pitch and roll is like a plane or a boat. That's yaw is around. So that's like spinning this way. Pitch and roll or side to side and forward and backward. But in particular, yaw, so the way we move, we turn and then move forward. Instead of when we go that way, we turn and move forward and looking in a different direction and everything. We'll see that movement soon. I just wanted to look at a few things to get ready for the game. So get input controls. Then we need to do some 2D stuff to prepare for the first game, look at tile sets. But it's probably a good time for a break first. And in general today, you're going to want to spend a bunch of time thinking around, put a rigid body in there and look through the inspector at all those options you have. Look at what the default script for the rigid body has. And we have all of these things in 2D and 3D in all our major game engines. Nice thing about Godot is 2D and 3D are exactly the same. Some of our other big ones, 2D and 3D, are very, very different. It's like they're not even related to each other. They clearly follow the same model. But let's take a break first. 10 minutes sound good to everybody? My clock says 2:11, so we'll get back to it at 2:21 and look at the input manager. We'll change to what those controls are, and then adjust that movement so that it's more appropriate. Remember, I kept making a big deal about acceleration. We want to use acceleration, not just change our position. And then we'll look at tile sets so y'all can get started on the next game. So I will see you in just a moment.